So in this video, we are going to see another problem from exercise 8.1, and this is problem number 9. Now let's read the problem. In triangle ABC, right angled at B, if tan A is equal to 1 by root 3, find the value of, and this is expression number 1, this is expression number 2. Basically, we need sine and cos of both the angles A and C. It is right angle at B. So let's first try to draw this right angle triangle. So here is our representation of a right angle triangle. Okay, and this is triangle ABC, which is right angle at B. So I'm going to make this as B, this is A, and this is C. Okay, so let's once again read the statement. In triangle ABC, right angled at B, so right angle at B. So let's confirm that whatever we are drawing is what the question has asked us. Now tan of A is 1 by root 3. So the angle on focus is this A. Tan of A is given as 1 by root 3. Find the value of these many expressions. Now basically, in order to find the values of sin A and cos A, or in fact to find the value of any trigonometric ratio, we should know the length of the sides of triangle. All the three sides of the triangle, we should know their length. So our step 1 is going to be, let me note it down, step number 1 is going to be find length of all the sides of triangle ABC. Okay, we should find the length of all the sides of triangle ABC. Now in order to do this, we are giving this information. This information is given to us that tan A is equal to 1 by root 3. So let's manipulate that information. So let us continue. So I'm going to write here tan of A. This is given. Tan of A is equal to 1 by root 3. Now this is also equal to, what is the definition of tan A trigonometric ratio? The definition is side opposite to angle A divided by side adjacent to angle A. This is the standard definition of tan A. Now, what is the side opposite to angle A? Based on this diagram, side opposite to angle A is BC. So I'm going to write it down. This is equal to BC, the whole divided by, what is the side adjacent to angle A? This is our angle A, and this is the side adjacent. This side is the hypotenuse side, which is the side opposite to the right angle. So side adjacent to angle A is AB. So that is equal to AB. Okay. Therefore, we get 1 by root 3 as equal to BC by AB. So we have got the ratio of length of BC by AB, which is 1 by root 3. We want to find the length of all the sides of triangle ABC. Okay. So we manipulate this information and we continue. We say let K be the common factor. Okay. Let K be the common factor for this ratio. And therefore, we get BC as equal to 1 into K. Okay. And we get AB as equal to root 3 into K. This becomes the length of the sides of triangle ABC. Now, let's substitute these two sides, length of sides in the triangle. Okay. So we have BC as equal to K, and we have AB as equal to root 3K. Okay. Now let's focus on this triangle. Now this is our right angle triangle. Okay, ABC, and we know two sides. We know length of two sides. We have to find the length of the third side. So very obviously, we are going to use the Pythagoras theorem. So I'm going to write it down. Using Pythagoras theorem, we have AC square as equal to AB square plus BC square. Okay, let's substitute the values. This is going to be root 3K the whole square plus this is going to be K the whole square. Now that is equal to 3K square plus K square. Sorry, what is 3K square plus K square? That is equal to 4K square. So 4K square, and therefore we get AC square as equal to 4K square. And therefore now we take square root on both the sides of the equation. So AC is equal to under root of 4K k square, and that is equal to 2k, because 4 is a perfect square, so square root of 4 is 2, and k square is a perfect square, square root of k square is equal to k, and thus we get AC as equal to 2k. Now let's make a note of this in the triangle. So AC is equal to 2k. Now thus, if you look at this triangle, let's zoom in. If you look at this triangle ABC, we know length of all the three sides of the triangle. So step 1 is completed. Our step 1 was to find the length of all the sides of triangle ABC. So we have found the length of all the three sides of triangle ABC. Now we need to find these values individually, sin A, cos C, cos A, sin C, and we will substitute in these expressions. So what I am going to do is, we are going to take this triangle down, copy. So let's bring it here, paste. Okay. So we have got this here now. Okay. Now let us quickly find out the individual values of sin A, cos C, cos A, and sin C. Okay. So let's start with A. So now we know that sine of A is nothing but equal to the opposite of angle A, which is BC, divided by hypotenuse, which is AC. So BC divided by AC, that is equal to K divided by 2K, that is equal to 1 by 2. Now similarly, we have cos of A. Cos of A is equal to adjacent A, which is AB, adjacent side to angle A, divided by hypotenuse, that is going to be AC. AB is root 3K, the whole divided by 2K, that is equal to root 3 divided by 2. Now similarly, we are going to find out, so yes, we are going to find out sine of C. Sine of C is equal to opposite side, which is AB, divided by hypotenuse, which is AC. So AB is again root 3K and AC is equal to 2K. So that is equal to root 3 by 2. And then we have to find out cos of C. Cos of C is equal to adjacent to C is BC, the whole divided by hypotenuse, which is AC. But BC is K and AC is 2K. So that is also going to be half. Okay. So we now thus have all the values of sin A, cos A, sin C, cos C here with us. We can easily find the values of these expressions. So let's start with the first expression, sin A into cos C plus cos A into sin C. So okay. So I'm going to use the space here. Let me draw a straight line here. Yes. So this is my first expression. Okay. Sin A into cos C. Okay, let me write it down. Sin A into cos C plus cos A into sin C. This is my first expression. Now, what is sin A? Sin A is half. What is cos C? Cos C is also half. Plus, what is cos A? Root 3 by 2. And what is sin C? It is also root 3 by 2. So this is clearly equal to 1 by 4 plus root 3 into root 3 is 3 divided by 4. And that is equal to, numerators are same, so 1 by 3 the whole divided by 4, that is equal to 4 divided by 4, that is equal to 1. So the value of the first expression is 1. So I'm going to just write here 1. Now similarly, let's calculate the value of the second expression, cos A into cos C. So where should I write it down? Okay, let me write it down here itself. Let's draw a straight line here first. So expression, oops, yes. So expression number 2 is, yes, cos A into cos C minus sin A into sin C. So now let's use all these values that we have derived here to find this value. So cos A is root 3 by 2 into cos C, which is half, minus sin A is half and sin C is root 3 by 2. Okay, so you can clearly see this expression and this expression are same. So it's going to be equal to 0. So this is in fact going to be root 3 by 4 minus root 3 by 4. and that is going to be equal to 0. So the value of the second expression is equal to 0. So thus, using this information that in triangle ABC tan A was 1 by root 3, we have found out the value of expression number 1 and expression number 2.